My name is Feigl. I'm a professor at the University of Wisconsin-Madison.
Okay. Please describe your current work.
I like to watch things that move. I'm measuring deformation of volcanoes, earthquake-generating faults, and glaciers, and now subsidence created by withdrawal of fluids such as gas, oil, and water.
Would you call yourself a geophysicist?
Yes, proudly.
And remember,
Yes.
you have to
Right.
kind of state the question.
Yes, I would call myself a geophysicist. I also call myself a geodesist. I measure the shape of the earth and how it changes with time.
How does your current work relate to the work you did with the TI 4100?
I got my start as a graduate student working in California. We used the TI 4100 instruments, some of the earliest civilian GPS receivers, to measure the deformation associated with the San Andreas Fault in California. And in some ways, I'm still at it. We're still working on it, getting more and more precise measurements. We use lighter weight antennas and GPS instruments now. More recently, we've been able to make measurements of the same kinds of deformation using sequential measurements or sequential images acquired by a radar satellite. So has a number of advantages and disadvantages. One is we don't get to go out in the field anymore. And in the old days, graduate students were sent out to babysit the instruments because the instrument was worth more than we were paid for 5 years of thesis.
Sorry, is the mic in your left pocket?
It's in my right pocket.
Okay.
You see it?
Carry on. No, I was just hearing a little bit of static. I thought it might have been, but it's fine. Sounds good. Carry on.
Okay.
Sorry.
Okay.
When did you work with the TI 4100?
I won't reveal how old I was then because you'll figure out how old I am now, but in 1985, where I learned how to set up one of these tripods and antennas on the roof of a building in Caltech in Los Angeles. Was taught by a branch chief of the U.S. Geological Survey, William Prescott, who later went on to become president of the UNAVCO facility here in Boulder.
What work were you doing with the TI 4100?
We were at that time making the earliest measurements using GPS of the San Andreas Fault motion. We were looking for about 1.5 inches of motion per year spread out from Point Conception on the west side of the fault to Bakersfield on the east side of the fault.
So how far up and down the San Andreas Fault did you go?
We got to what was called Central California, up to about San Luis Obispo and almost down to the Mexican-U.S. border.
You already answered that. Where did you use the instrument? Okay. Have you ever used an instrument or technique like that before?
Before that, yes. I worked as a shipboard technician using one of the first civilian receivers for shipboard navigation. It was a Magnavox receiver. I did that the year before I used the land version. So that was how I got my interest started in GPS.
Did you have to set up a tripod on the ship?
Nope, it was on top. The tripod was mounted on the top of a mast on the not a sailing ship, on top of a mast. And my first thing I had to do as a shipboard technician was to climb the top of the mast.
Was it a research vessel?
Yes, it was the research vessel RV Conrad.
Who trained you to use the instrument, and what was the most difficult part of training?
The person who trained me to set up a GPS instrument was the then director of the crustal strain group at the U.S. Geological Survey, William Prescott. The hardest part about it was getting the antenna leveled with a tripod at 6 degrees of freedom, lots of fooling around. And then even harder than that is measuring the height of the antenna with a low-tech instrument called a tape measure. But it's surprisingly hard to do and hard to get it right.
Was the tape measure in inches or centimeters?
We eventually learned to use both, but if those of us who spent some time in Europe would get confused with the inches, and those of us who grew up in the States would get confused with the centimeters. And I've actually seen a tenured professor at MIT, of all places, make an error of 30 centimeters, 1 foot, because it was only in centimeters.
What was the most difficult part about using the instrument?
The most difficult part of using the instrument was getting it there. The TI 4100 came in 2 boxes. One was 50 pounds and the other was 70 pounds. And that doesn't count the truck batteries. Deep cycle marine batteries about this big, and those are another 40 pounds each. And we needed 2 of them just to run for 5 hours. And did I mention that we had to do this in California at night, because that was the only time the satellites were overhead. It was before the collection of GPS satellites called the Constellation was complete. So time, tide, and satellite wait for no man and damn few women.
So did you have a lot of graduate students carrying the load?
I was a graduate student, yes. The graduate students were responsible for not only carrying the instruments and the batteries up and down the hill, but also babysitting them. Sometimes the professors went home and got some sleep.
So you left them out in the field like all day long? And
they stayed out all night, and we stayed out with them because we were we were worth less than they were. It was $100,000 per instrument at the time.
Okay, what was the most exciting part about using the instrument?
The most exciting part about the instrument, exciting is the wrong word for for babysitting an antenna, because once you get there, there's not that much to do. The time we measured meteorological observations, the temperature and the relative humidity and things like that, it took a while. It kept us busy, but once an hour we had to wake up, write things down on our clipboard, and graduate students would argue about whether we actually used those measurements for anything.
So what about the data? So you would collect data. So what was the most exciting part of the data that you collected with that instrument? I mean, when you first got your data, was it like,
there was one exciting time when looking at two different weeks of observations done by 2 different people in the same place. We thought we saw an offset of over 30 centimeters. We thought it was a foot of motion. We thought it was an earthquake, and it turned out to be the professor measuring the antenna height wrong.
Okay. What's the biggest benefit of using the instrument?
The precision. We get now millimeter level accuracy and precision, and that's just what we want to know if we want to understand the processes driving earthquakes, volcanic eruptions, and glacial flow related to climate change.
Could you state that as the biggest benefit of the instrument?
The biggest benefit is the precision, and that allows us to understand these processes that are driving the deformation below volcanoes and associated with earthquakes. And if we can understand those processes, we can do a better job of helping people live on this planet safely.
Did you leave your mark on the instrument?
Did I leave my mark on the instrument? No, we were instructed not to write on it. The example we have here was signed on as a retirement gift to William Prescott, the individual who instructed me how to use them. But we're not supposed to mark up the instrument.
Did you ever drop it?
I plead the fifth.
Okay. Did the instrument leave a mark on you?
Oh, definitely. And I still use it as a way of thinking about designing better instruments, and I use it as a way of interpreting the satellite imagery that we're working on as the next generation of geodetic data. And so it left a mark on me in my mind, but almost left a mark on me in a story. Or we were working on a summit in California where we weren't allowed to drive, and we couldn't drive because it was on a California condor reserve. So it was a nature preserve. So we had to walk up with the 50-pound box, the 70-pound box, and 2 truck batteries. And we walked up with a colleague of mine who now works at NASA Jet Propulsion Lab. He was used to hard labor. He'd survived the Cultural Revolution in China. And his English was always very colorful and expressive, but not always grammatically correct. So we put the batteries and the cases on backpacks and hauled it up the hill. And I was walking first because I knew where the benchmark was. And I hear my friend say, "Kurt, back on fire." Back on fire, I said. So I turn around, and I don't see any fire. I mean, I was thinking forest fire. It was a dry part of the year in California. My friend looks around and says, obviously he doesn't understand, so I'll repeat it. "Kurt, back on fire." So I turn around again. I still don't see it. And then he comes up and touches me and says, "You're back on fire." What had happened was the metal case had short-circuited the battery and had ignited the burlap bag that we used to protect the battery and the case from each other. There's battery acid leaking off the battery, and so short-circuiting the battery caused a fire in the burlap bag, and we put the backpack down and put out the fire. Didn't start a forest fire, but almost burned my back, but didn't.
Wow. Yeah. Okay. Do you have a fond memory about the instrument to share?
Well, that was a fun trip. Fond memories. I'm not prepared for that question.
Were you ever drinking a beer by your instrument, or
graduate students never do that.
Yes, that's true. I don't want to get you in trouble. Okay, how did the instrument contribute to advancing your work?
As a result of probably 500 graduate student days of babysitting, we were able to publish a big paper in the peer-reviewed literature, peer-reviewed journal, and that was the next step in understanding how the plates slide past each other in California along the boundary, which is the San Andreas Fault.
So you could get the offset on the San Andreas Fault, the rate of motion?
Yes, we could measure the rate of motion along the San Andreas Fault, and we decreased the uncertainty on that, increased our confidence from 4 or 5 millimeters per year down to 1 or 2 in terms of precision.
Have you used modern instruments for the same or similar work, and how have the instruments or the work changed?
Yes, we've used more modern versions of the instruments. Some things have changed. The biggest improvement is the whole system is lighter and uses less power. They've gotten cheaper, so now we're willing to deploy them in the field without a babysitter. And now we have continuous stations where the instrument sits out there by itself and measures continuously, and most of the time the data are transmitted remotely to a laboratory where we can analyze them directly. So the change is that we don't get to go out in the field anymore. The advantage is we don't have to.
And it's 24/7 because you have a full constellation.
Yes, continuous GPS, and now the constellation is complete since about 1991. The satellites are operating 24/7, and there are several thousand operating continuously several thousand receivers and stations operating in the U.S. alone, collecting data almost every 15 seconds for 24/7.
Do you have any other comments you'd like to relate about the instrument and history?
The TI-4100 was a nice spin-off. The GPS was built by designed by the military. The TI-4100 was originally designed for military use, and it has blossomed into something which is much bigger than just defense related, and part of that is because of the commercial and civilian applications. Now the scientists are just a very tiny part of that market.
Okay. I think it would be good if we went back to the mark question and
Sure.
you hold that up.
Okay.
Yeah. Okay.
I haven't left a mark on it, but is that the one you want to talk about?
Yeah. So I'll give you the question. Did you leave your mark on the instrument? And then...
No, I didn't leave a mark on the instrument. The one I'm holding, which is just the antenna, the lightest part of the whole system, was signed by a number of colleagues as a retirement gift for William Prescott, who was one of the first presidents of the UNAVCO facility that deploys these instruments and served to share them wisely among scientists who needed them.
Did you rotate it?
Sure.
Can you just
So,
I'm gonna zoom in?
so there's Jamie's signature. Mike Jackson signed it.
Looks like Will Prescott signed it too.
Yeah, it says George Bush. Great job, Will. I'm not sure if that's a real signature. William Prescott signed it there.